Hey, I'm Scott Chacon, CEO of GitButler. Today, Caleb and I are going to be making a CLI in Rust. I am here again, once again, by popular demand, with Caleb Owens, another butler. And today, we are going to follow up on our very popular Tory episode with an episode on Rust CLI.
Yes!
Because we're releasing our CLI here pretty soon. The thing that we want to do is a simple version of how to write a CLI in Rust.
Yeah.
The nice thing about Rust, and the thing I really love about Rust, is that it's very easy. It's a compiled language, right? So it's very easy to distribute across all of the operating systems, Mac, Windows, Linux, to say, here is a CLI. It works the same sort of everywhere, right? And we don't have to deal with having like an interpreted language like Ruby or Python or something.
Being able to make that compiled bundle is super cool.
Right, it's amazing.
In a similar vein, if you want to write either TypeScript or JavaScript, now with both Bun and Dino, you can create a executable that will include the entire JS runtime and the relevant JS files in one single binary package.
So are you saying it's dumb to do stuff in Rust? Or if you were I want to do this CLI sort of interface, would you do it in JavaScript or would you do it in Rust? Please say Rust, because that's the point of this episode.
It's a very good question. I think both of them have their strengths and their weaknesses. I think if I wanted to build a company and I wanted to build a really strong technology, I would choose to build it in Rust because the compiler is very strict, but that also gives you reasonable assurance about correctness.
But the binary is small, right? Like compared to bundling an entire JavaScript runtime.
That is another thing. If you're compiling a Rust library, it will statically link a couple of low-level dependencies, but reasonably it's much smaller than including the entire V8 runtime.
Presumably faster, right?
Oh, 100% faster, yeah.
Let's assume that our audience, our beautiful audience over here,
wonderful audience,
wants to do a CLI of something, of some tool, right?
Yeah.
And so we're going to show how to do this with Clap, with Rust, of saying here's how to build a CLI tool in Rust. And before we get to the bits, we are going to get to the booze. I think we're going to start with this South African red wine.
Ooh, that's cool.
Have you had a South African red wine before?
I've not. I've had some South African white wines. They were like a champagne style wine, but not today, Scott.
Oh, you're doing it. Okay. What we have here is Alvi's Drift from South Africa.
Yeah.
It's a Stellenbosch region. So there's a handful of famous wine regions. Why are you pouring so much more for you? It's from the Stellenbosch region. It is a Pinotage.
Pinotage? I've not heard that before.
So it is a grape that is essentially only grown in South Africa, as far as I know. It is a combination of a Pinot Noir and a Cinsault. It's a little bit darker, I think, than a normal Pinot Noir.
Yeah, I was going to say,
you would find in France.
It does have that. It does have that level of body to it, but it's also got that deeper, almost chocolatey flavor.
It is. This is actually pretty nice. I like this one.
So, Scott Chacon.
Yes.
You said you wanted to make a CLI tool.
Can you tell me
what sort of a CLI tool would you like me to build you today?
I would like to track the wines that I drink.
Okay.
So let's make a CLI that keeps a database of the wines that I drink. I can add stuff to it. I can see what wines I have. I think it would be very nice to say, what have I dranken? Is that the past tense?
Drunk.
What have I drunk?
Yeah. So let's start out by creating a new project in Rust. So we do that by saying cargo. And cargo is the main package manager. So it's NPM for Rust.
Right.
So I'll say cargo new for new project. And what do you want to call this?
Wino.
Wino.
All right, so we have our new Wino project. What happens when you do that? What does it put into your directory?
Let's take a look at that. So I'm gonna open this in my code editor. So whenever I say cargo new, it assumes I want to make like some sort of executable tool.
Cargo.toml. Do you know where toml comes from?
Yes, it's called Tom's only markup language. And objectively, it's one of the worst markup languages I've ever seen.
By the way, it's my friend Tom.
I know it's your friend Tom.
So this actually really came from YAML, right? Like YAML had these, like all these problems with YAML, and so Tom was like, okay, let's like at least have a spec for how this should be done. Okay,
and
but
YAML,
what do you not like about toml?
I was experimenting doing like embedding of Git history for Git Butler to sort of do like semantic lookup of history. And I originally started off by storing these embeddings in a toml file. And beyond about sort of like 50 or 60 entries, the performance of parsing the toml file was actually detrimental to the process.
Is that because of the format of toml, or is that because of the implementation of the toml parser that you were using?
Reasonably, you could say it's the toml parser at fault, but the toml parser that I was using, which was the toml extension for CERD, is one of the most used like toml parsers because of cargo. With the way that I was using it, which was not unreasonable, it was getting detrimentally slow with relatively little data.
Fair enough.
Because of how hard the syntax is for a computer to parse.
I see.
We've just run cargo new, which has set up a like very empty product for us. So what this does is it gives us this cargo toml, which says, here is the like package name and like a version. And the most important
thing, an addition for a year that is 1 year earlier than we are in now.
So the addition actually specifies which like major version of the Rust programming language we want to use. So for a while, this used to be Rust 2021. And about 5 months ago, we switched over to Rust 2024, which brought a bunch of improvements to the Rust borrow checker, making it much more granular, which actually makes the borrow checker more easy to work with because it's more intelligent about how it determines the lifetime of objects.
It's hard to say that the Rust borrow checker could be more easy to work with than it is currently. But
no. I think it's hard to say that the Rust borrow checker is harder to work with. It's always easier.
All right, fair enough. So now we have our Wino app.
So initially, Rust will give us just this very basic like main function with like a print line thing.
Right.
But if we want to build like a CLI application, there are a couple of dependencies that we want to include.
Which is?
So for the tool that I think we want to build, you're going to give me some more instructions as we go along.
Right. So we want to say, add a wine. Let's add this wine. Let's add Alvy's Drift 221. And we like it.
The first library that I want to add is this one called Anyhow. And Anyhow is
for error checking.
Yeah, it's this library that helps us do error checking in a more ergonomic way, right? Because I think a lot of you will have heard about sort of like just calling unwrap on everything.
I want to call unwrap on everything.
I know you do.
I love Christmas. I love unwrapping.
Yeah. There's this library that sort of taps into this particular syntax of Rust that helps with that and does it in a more ergonomic way. And there's another library called clap. This is the important one, Pat. So clap is this command.
Why are you pulling Pat into this?
Clap is this library that's commonly used as a command line argument parser. That's what clap stands for. And I'm going to use two more libraries. So we want to have this CLI tool that we can sort of rate wines. So we need some sort of way of persisting this data to the hard drive.
Database, yeah.
So I'm going to use the library called SERD, which stands for serialize, deserialize.
Is that what that stands for?
Yes.
I did not know that. I did not know that.
And I'm going to use the extension library SERD JSON to serialize and deserialize JSON files.
All right, so we're gonna, everything that we're doing to store our wine ratings is gonna be in a JSON file. And we're gonna use SERD for that. All right, so let's do it.
So we're going to start off by adding these libraries to our repository. So I'm going to say cargo add clap
$dollar bill, y'all.
$.
Boy, it adds a lot of shit.
It does add a lot of shit. I'm also going to add cert. So this is just version 1. And one of the things I'm going to do is I'm going to use the derive feature. So this includes some Rust macros that help sort of more like ergonomically define the parser. And this is the same setup that we have in Git Butler for the Rust CLI that we make. So I'm going to just hop into the cargo toml here.
Hop right in.
And I'm going to paste this in. And
what's the... Oh, okay. I thought it was, I was looking at clap and cert as different dependencies. They both have features derive. Like, why do they both have derive features?
So these libraries want to provide the ability to use them without macro usage. But for most applications, you usually want to use them with the derive features. So
that gives you the macros that you can put on top of the things?
Yeah. So if I've got a particular struct, I can say derive serialize and derive deserialize. And SERD will try and figure out, based on the structure of this struct, like how can I convert this to JSON automatically?
So if you have a weird data structure, right, and it can't automatically derive it, right? Like derive is good for strings and integers and things like that. If you have like a more complex thing, how do you, well, maybe we can get into this later. But
no, this is a really good question. In Git Butler, there are a couple data formats that we want to send to our front end because we build a Tauri application. So we've got a web front end with Rust as the back end. There are a couple data formats that we want to send across that barrier. But SERD doesn't know how to like serialize or deserialize that automatically. In Git Butler, if we take a look at the but SERD crate, we can take a look at one example, which is the B string. So a B string is an array of 8-bit integers. So we have this serialization for a B string that like makes sense for our front end. With SERD, we can define these like serialize and deserialize implementations. And essentially, we can take a type that SERD doesn't support and build our own serialization such that SERD can now like work with these types.
Okay.
So in some of the past episodes where we've done Rust programming, we have just like allowed
unwrap.
We've called unwrap, which causes runtime panics. In this episode, I'm going to insist that we do
not unwrap.
We don't unwrap.
We question mark.
We question mark. So anyhow is this library that is really helpful for writing like applications in Rust, where it's like the errors reasonably aren't going to be reconsumed. So just being able to throw, hey, there was a problem is a helpful thing to do. And anyhow helps us with that. So like the most basic way of anyhowing up your library is just to say use anyhow result.
Nope, not even close.
Which imports the result type. And on our main function, we can say, rather than returning void, which is the default, we can return a result of a unit. And we can say, no matter what happens, we're going to return this unit type at the end of this main function. So this allows us to have like error propagation through different functions in the application. Beyond that, we want to make a CLI application. So we want to start setting up the like clap library to be able to parse these arguments. So the first thing we want to do is we want to have a main struct. So we'll say struct args. What we want to do in our case is have a sort of set of subcommands, I think. So we want to have like a list subcommand to list out the different wines that we've previously reviewed.
Sure.
And we want to have a command to add a new flavor of wine. So I'm going to say this struct has a command, like subcommand, which is a subcommand struct. So I'm going to say struct subcommand is a enum. So this means I can have sort of different things that are subcommands. So in our case, we'll probably want to have add, and we're probably going to want to have a list as well. So in order to set these up with clap, there are some extra like macros that we want to add. And macros are a way of telling the Rust compiler, can you like add this extra functionality to a given structure for us? So for clap, it specifies in the documentation that we want to have these like derive macros. So we're going to derive parser, which means that we can parse like command line syntax. And in here, they've also added debug, which just allows you to print the struct as a debug output.
What does that mean?
So in a language that's sensible like Ruby, you can say pretty much like puts and then any given object, and it will provide an output that describes that object to the command line. In Rust, by default, you can't do that. So if you want to say provide some debug output whenever I say print line, you have to derive the debug macro, which will create a serialization for your given structure.
So what happens if you say derive parser and you leave debug out?
In terms of what clap does, it would make no difference. I'm going to steal their sort of macros that they sort of have in their example, and I'm going to move them over to our example here. So the version lets us like specify a version number. I think about and long about allow us to sort of have some sort of like doc strings related to it.
Sure.
But the main thing that we want to do is to sort of say, this is our main like entry point to the application. And we've got our enum, which is this subcommand.
Yeah.
So here to register our main subcommand, what we want to do is say clap subcommand. So clap, the macro expander knows that this thing that's provided here should be considered like a subcommand of our interface. And if I then come in here and say derive subcommand, this means now that clap is going to import it, of course. Clap knows that this is a particular subcommand, and I should also derive debug for this. So I've got my enum called subcmd, which is my subcommand, and I've got my main like argument sort of thing. So what we can now do is say in here like args.parse.
That's not how you spell args.
Fuck you. So we can say let args equals.
Let args equal whatever you want.
I'm trying really hard, and because we've got say multiple subcommands, what I can do is I can use a match block, which pattern matches. So I can say match args.subcommand, and then I can say if I've got subcommand add, we print line adding a thing, or whoop, or I can say subcommand list and print line that I am listing a thing.
All right, let's try it out.
So now if I head to my command line, I can use cargo run, which runs the binary.
Sure.
So I say cargo run dash dash, and it requires me to do dash dash just so it knows that I'm doing a argument that should be sent to the binary rather than something that should be sent to the compiler.
Right.
So I can say dash dash list, and this will compile, and it'll say I'm listing a thing. Or I can say add, and it will say I'm adding a thing.
So it's all right. So we're doing the two different things. So now let's add a thing and list a thing.
So we've got this basic sort of command line parser set up here with our arguments and our subcommand. So the next thing that we want to do is we want to have a function that can both read the existing, say, configuration or the existing database, and we want to have a function to write that back to disk. So that's sort of covering like the basics of like command parsing and subcommands. Is there much more that I can show you?
I mean, the thing is, I'd really like to see how you, well, A, we need to implement this, but B, I want some flags on add and list.
Okay.
But in order to incentivize you, let's savor something.
Ooh.
All right.